Hi guys, welcome to my study compass. In this video, I'll be walking you through the past paper, Math P4, Variant 3, October-November 2018. Let's get started. Describe fully the single transformation that maps triangle T onto triangle P. When we look at triangle T and triangle P, they have the same size but their orientation is different, which means the transformation is either a reflection or a rotation. In this case, we see that triangle P is a mirror image of triangle T in the line y equals -1. And so the full description for the transformation is reflection in the line y equals -1. Translate triangle T by the vector -2, -5. For this translation, the translation vector dictates that we move each of the vertices of triangle T 2 units to the left and 5 units downwards. On the diagram, the movement for point A has been shown. After repeating the same process for all the other points as well, we are able to map out the translated image of triangle T. Rotate triangle T through 90 degrees anti-clockwise about 0, 0. First, we need to mark the center of rotation, which is the origin. Then we rotate each vertex on triangle T 90 degrees in the anti-clockwise direction about the center. This means if, let's say, we pick point B, we draw a line from point B to the origin. Then we measure and mark 90 degrees in the anti-clockwise direction from this line. From here, we draw a line from the origin, passing through the 90-degree mark. The final step is to now mark the new position of point B on this line, such that the distance from this new position to the center of rotation is the same as the distance from the center of rotation to the original position of point B. After repeating the same process for all the vertices on triangle T, we are now able to map out the rotated image of triangle T. Enlarge triangle T by scale factor -half with center 0, 0. First, we need to mark the center of enlargement, which is the origin. Then we need to move each vertex on triangle T such that we are able to reproduce the enlarged image of the triangle. Let's pick point B. To move from the center of enlargement to point B, we move 2 units to the right and 2 units upwards. The scale factor is -half. This means to pin the new position of point B, we are going to move half the distance we moved initially in the opposite direction. So we move 1 unit to the left and 1 unit downwards. After repeating the same process for all the vertices on triangle T, we are now able to map out the enlarged image of triangle T. Find the column vector AB. AB equals OB minus OA. OB is 5, 6. OA is 3, 2. To get the resulting vector, we subtract the corresponding elements. So 5 minus 3 is 2 and 6 minus 2 is 4. So we have 2, 4. Find the magnitude of vector AB. In this case, we apply the magnitude of a vector formula and this is what we get. When we type this into the calculator, we get 4.47 rounded to 3 significant figures. B is the midpoint of the line AC. Find the coordinate of C. By applying the midpoint formula, we have 3 plus the x-coordinate of C divided by 2 equals 5. This gives us x to be 7. Then we have 2 plus the y-coordinate of C divided by 2 equals 6. This gives us y to be 10. So we have 7, 10. Find the equation of the straight line that passes through A and B. All we need to do is find the values of m and c and plug in these values into y equals mx plus c. To get the gradient m of the line, we apply the gradient formula. This gives us 6 minus 2 over 5 minus 3, which is equal to 2. To get c, we plug in the value of m and one set of coordinates into y equals mx plus c. In this case, we are using the coordinates of a, so we have 2 equals 2 times 3 plus c. When we make c the subject, we get c equals -4, so we have y equals 2x minus 4. The straight line that passes through A and B cuts the y-axis at D. Write down the coordinates of D. At the point where AB cuts the y-axis, the x-coordinate is 0. When we plug in x equals 0 into the equation of AB, we get the y-coordinate to be -4. A school has 240 students. The ratio girls is to boys equals 25 is to 23. Show that the number of boys is 115. To get the number of boys, we divide the ratio share for the boys, which is 23, by the total ratio of 25 plus 23 times the total number of students, which is 240. This gives us 115. One day, there are 15 girls absent and 15 boys absent. Find the ratio girls is to boys in school on this day. Give your answer in its simplest form. On this given day, the number of girls would be 125 minus 15, which is equal to 110, and the number of boys would be 115 minus 15, which is equal to 100. The common factor is 10. When we divide through the ratio by 10, we get 11 is to 10, which cannot be simplified further. Next year, the number of students will increase by 15%. Calculate the number of students next year. If the number of students will increase by 15%, then we add 15% to 100%, giving us 115%. So the number of students for next year would be 115% of 240, which is equal to 276. Since the school was opened, the number of students has increased by 60%. There are now 240 students. Calculate the number of students when the school was opened. The current number of students, which is 240, is equal to 160% of the number of students when the school was opened, which is what we are calling n. When we make n the subject, this is what we have, which is equal to 150. The population of a city is increasing exponentially at a rate of 2% each year. The population now is 256,000. Calculate the population after 30 years. Give your answer correct to the nearest thousand. In this case, we need to apply the compound or exponential formula. Big A represents the final value of the population, which is what we are finding. Small a represents the initial value of the population, which has been given as 256,000. The annual rate R is 2% and T is 30 years. When we type this into the calculator, this is what we get. The number in the thousands position is 3. The number after 3, which is 7, is greater than 5, so we add 1 to 3, giving us 4. And all the numbers after 3 become 0, so we have 464,000 rounded to the nearest thousand. A bacteria population increases exponentially at a rate of R% each day. After 32 days, the population has increased by 309%. Find the value of R. In this case as well, we need to apply the exponential formula. When we make R the subject, this is what we have. The time t is 32 days. Small a represents the initial population. Big A represents the final population. We are told the final population increased by 309%. This means the final population is equal to the initial population A plus the increase, which is 309% of A. This gives us 4.09A. The A cancels out. When we type this into the calculator, we get the daily rate to be 4.50, rounded to 3 significant figures. The diagram shows a solid cone. The radius is 8 centimeters and the slant height is 17 centimeters. Calculate the curved surface area of the cone. We've been given the formula for the curved surface of a cone as pi rl. The radius r in this case is 8 centimeters and the slant height l is 17 centimeters. When we type this into the calculator, we get 427 centimeters squared, rounded to 3 significant figures. Calculate the volume of the cone. We've been given the formula for the volume of the cone as 1 over 3 pi r squared h. We know the radius r of the cone is 8 centimeters. We've not been given the perpendicular height h of the cone. We can find h by applying the Pythagoras theorem to the right-angled triangle formed between the perpendicular height, the base, and the slant height. This gives us 17 squared equals h squared plus 8 squared. When we make h the subject, this is what we have, which is equal to 15. So now we plug in the value of h into the volume equation. When we type this into the calculator, we get 1010 centimeters cubed, rounded to 3 significant figures. The cone is made of wood and 1 centimeter cubed of the wood has a mass of 0.8 grams. Calculate the mass of the cone. If 1 centimeter cubed of wood has a mass of 0.8 grams, then what would be the mass if we have a volume of 1010 centimeters cubed? This is what we are calling x. When we cross multiply and make x the subject, this is what we get, which is equal to 808 grams. The cone is placed in a box. The total mass of the cone in the box is 1.2 kilograms. Calculate the mass of the box. Give your answer in grams. To get the mass of the box, we simply subtract the mass of the cone, which is 808 grams, from their total mass, which is 1.2 kilograms. We convert 1.2 kilograms to grams by multiplying 1.2 by 1000. This gives us 392 grams. The diagram shows a solid cylinder and a solid sphere. The cylinder has radius 3r and height 8r. The sphere has radius r. Find the volume of the sphere as a fraction of the volume of the cylinder. Give your answer in its lowest terms. In other words, we are to find the volume of the sphere divided by the volume of the cylinder. The formula for the volume of a sphere has been given as 4 over 3 pi r cubed, where the radius r has been given as r in this case. The formula for the volume of a cylinder is pi r squared h, where the radius r has been given as 3r and the height h has been given as 8r. Pi times 3r squared times 8r simplifies to 72 pi r cubed. Pi r cubed cancels out. 4 over 3 divided by 72 gives us 1 over 54. The surface area of the sphere is 81 pi centimeters squared. Find the curved surface area of the cylinder. Give your answer in terms of pi. Here is the formula for the area of the curved surface of a cylinder. The radius r is 3r and the height h is 8r. 2 pi times 3 times 8 is 48 pi. R times r is r squared. We need to find r. We know that the surface area of the sphere is 81 pi. When we divide both sides by 4 pi, this is what we have. When we take square root of both sides, this is what we have, which is equal to 4.5. Now that we have the value of r, the curved surface of the cylinder is 48 pi times 4.5 centimeters squared, which is equal to 972 pi centimeters squared. F of x equals x squared over 4 minus 4 over x, where x cannot be 0. Complete the table for f of x. When we plug in x equals 2 into the equation, we get y equals -1. For x equals 4, we get y equals 3. The graph of y equals f of x for x is greater than and equal to -6 and less than and equal to -0.5 is drawn on the grid. On the same grid, draw the graph of y equals f of x for x is greater than and equal to 0.5 and less than and equal to 6. On the grid, we plot all the points in the table and connect the points with a smooth line. By drawing a suitable tangent, estimate the gradient of the graph of y equals f of x at the point -4, 5. On the grid, we've drawn the tangent to the graph at -4, 5. So now, we pick 2 points on the line to help us estimate the gradient. When we apply the gradient formula, this is what we get, which is equal to -5 over 3. G of x equals 9 over x, where x cannot be equal to 0. Complete the table for g of x. When we plug in x equals -3 into the equation, we get y equals -3. For x equals 3, we get y equals 3. On the grid, draw the graph of y equals g of x for x is greater than and equal to -4 and less than and equal to -1, and x is greater than and equal to 1 and less than and equal to 4. On the grid, we plot the points in the table and connect the points with a smooth line. Use your graphs to find the value of x when f of x equals g of x. In other words, we are to find the x-coordinate of the intersection point of the two graphs, y equals f of x and y equals g of x. On the grid, we see that the x-coordinate of this intersection point is 3.8. Write down an inequality to show the positive values of x for which f of x is greater than g of x. On the grid, in the positive x region, we see that after the point of intersection, f of x rises above g of x, or in other words, f of x is greater than g of x. In this region, the x values are greater than 3.8. The exact answer to part Fi is cube root of k. Use algebra to find the value of k. In part Fi, we solved the equation f of x equals g of x using the graph. So now we are to solve the same equation using algebra. F of x is x squared over 4 minus 4 over x. G of x is 9 over x. To clear the denominators, we multiply through the equation by the LCM, which is 4x. This gives us x cubed minus 16 equals 36. When we add 16 to both sides, we get x cubed equals 52. When we take cube root of both sides, we have x equals cube root of 52. When we compare this to what we were given in the question, we see that k equals 52. A factory recycles metal. The mass X tons of metal is measured each week. The table shows the results for 52 weeks. Calculate an estimate of the mean. The mean is equal to sigma f of x, which represents the total mass of metals, divided by sigma f, which is the sum of the frequencies. Before getting sigma f of x, we need to get a midpoint mass for each of the mass intervals. So for the first interval, the midpoint mass is 100 plus 200 divided by 2, which is 150. Then we have 200 plus 250 divided by 2, which is 225. 250 plus 300 divided by 2, which is 275. 300 plus 500 divided by 2, which is 400. So for sigma f of x, we have 150 times 8 plus 225 times 20 plus 275 times 12 plus 400 times 12 tons divided by 52. When we type this into the calculator, we get 265 tons, rounded to 3 significant figures. On the grid, draw a histogram to show the information in the table. To be able to draw the histogram to show the information given in the table, we need to calculate the frequency density for each of the given intervals. The frequency density is equal to the frequency divided by the interval width. For the first interval, the frequency density is equal to the frequency, which is 8, divided by the interval width, which is 200 minus 100, which is equal to 0.08. Then we have 20 divided by 250 minus 200, which is equal to 0.4. 12 divided by 300 minus 250, which is equal to 0.24. Then finally, 12 divided by 500 minus 300, which is equal to 0.06. After marking all the different intervals on the horizontal axis of the grid, we can map out their heights using their frequency density values. Another factory also recycles metal. The mass X tons of metal is measured each day for a number of days. The cumulative frequency diagram shows the results. For how many days was the mass measured? When we map the highest point on the graph to the vertical axis, we get 100. This means the mass was measured for 100 days. Find an estimate of the median. To get the median, we map half of 100, which is 50, onto the graph. This gives us the median to be 56 tons. Find an estimate of the upper quartile. To get the upper quartile, we map 3/4 of 100, which is 75, on the graph. This gives us the upper quartile to be 62 tons. Find an estimate of the interquartile range. The interquartile range is equal to the upper quartile minus the lower quartile. We've already found the upper quartile to be 62 tons. To get the lower quartile, we map 1/4 of 100, which is 25, on the graph. This gives us the lower quartile to be 38 tons. So 62 minus 38 gives us 24. Find an estimate of the number of days when the mass was greater than 20 tons. When we map 20 tons from the horizontal axis, we get 12, which represents the number of days when the mass was 20 tons or less. So to get the number of days when the mass was greater than 20 tons, we subtract 12 from 100, which gives us 88. Calculate angle ACB. To get angle ACB, we apply the cosine rule to triangle ABC, and this is what we get. 13 squared plus 4 squared is 185. 2 times 13 times 4 is 104. When we make angle ACB the subject, This is what we have. When we type this into the calculator, we get 52.0 degrees rounded to 1 decimal place. Calculate angle ACD. Based on the sides and angle given for triangle ACD, we can't find angle ACD directly from the sine rule, but we'll be able to get angle CAD. This means angle ACD would be equal to 180 degrees minus 80 degrees plus angle CAD. When we apply the sine rule to triangle ACD, this is what we have. When we make angle CAD the subject, this is what we get, which is equal to 37.3 degrees rounded to 1 decimal place. Now that we have angle CAD, then angle ACD would be 180 degrees minus 80 degrees plus 37.3 degrees, which is equal to 62.7 degrees. Calculate the area of the quadrilateral ABCD. The area of ABCD is equal to the area of triangle ABC plus the area of triangle ACD. When we apply the area of a triangle formula, half AB sine C, to both triangles, this is what we get. When we type this into the calculator, we get 66.7 centimeters squared rounded to 3 significant figures. Bag A contains 3 black balls and 2 white balls. Bag B contains 1 black ball and 3 white balls. A ball is taken at random from each bag. Show that a black ball is more likely to be taken from bag A than from bag B. The probability of picking a black ball from bag A is equal to the number of black balls in bag A, which is 3, divided by the total number of balls in the bag, which is 5. This is equal to 0.6. The probability of picking a black ball from bag B is equal to the number of black balls in bag B, which is 1, divided by the total number of balls in the bag, which is 4. This is equal to 0.25. The probability of picking a black ball from bag A is higher than the probability of picking a black ball from bag B. This simply means a black ball is more likely to be taken from bag A than bag B. Find the probability that the 2 balls have different colors. There are 2 scenarios in this case. A black ball is taken from bag A and a white ball is taken from bag B. Or a white ball is taken from bag A and a black ball is taken from bag B. The probability of taking a black ball from bag A is 3 over 5. The probability of taking a white ball from bag B is 3 over 4. The probability of taking a white ball from bag A is 2 over 5. The probability of taking a black ball from bag B is 1 over 4. When we type this into the calculator, we get 0.55. The balls are returned to their original bags. 3 balls are taken at random from bag A without replacement. Find the probability that they are all black. This probability is equal to the probability of picking a black ball from bag A the first time, picking a black ball the second time, and picking a black ball the third time. The probability of picking a black ball from bag A the first time is equal to the number of black balls in bag A, which is 3, divided by the total number of balls in the bag, which is 5. Without replacement, the pool reduces by 1, and so the probability of picking a black ball the second time is 2 over 4. Without replacement, the probability of picking a black ball the third time is 1 over 3. When we type this into the calculator, we get 0.1. Find the probability that they are all white. The total number of white balls in bag A is 2. So if the balls are picked and not replaced, the probability of picking 3 white balls from bag A is 0. The balls are returned to their original bags. A ball is taken at random from bag A and its color is recorded. This ball is then placed in bag B. A ball is taken at random from bag B. Find the probability that the ball taken from bag B has a different color to the ball taken from bag A. There are two possible scenarios in this case. In the first scenario, a black ball is taken from bag A and dropped in bag B, and a white ball is now taken from bag B. In the second scenario, a white ball is taken from bag A and dropped in bag B, and a black ball is now taken from bag B. Let's keep in mind that bag A contains 3 black and 2 white balls, and bag B contains 1 black and 3 white balls. The probability of picking a black ball from bag A is equal to the number of black balls in bag A, which is 3, divided by the total number of balls, which is 5. This ball is placed in bag B. So the probability of picking a white ball from bag B is equal to the number of white balls in the bag, which is 3, divided by the total number of balls, which is now 5. The probability of picking a white ball from bag A is equal to the number of white balls in bag A, which is 2, divided by the total number of balls, which is 5. This ball is placed in bag B. So the probability of picking a black ball from bag B is equal to the number of black balls in the bag, which is 1, divided by the total number of balls, which is now 5. When we type this into the calculator, we get 0.44. In the diagram, AB and CD are parallel. AD and BC intersect at right angles at the point X. AB is 10 centimeters, CD is 5 centimeters, AX is 8 centimeters, and BX is 6 centimeters. Use similar triangles to calculate dx. Since the two triangles are similar, then the ratio of their corresponding sides must be equal. So we have dx over 8 centimeters equals 5 centimeters over 10 centimeters. When we make dx the subject, this is what we have, which is equal to 4 centimeters. Calculate angle XAB. To get angle XAB, we apply SOHCAHTOA to triangle ABX. This gives us cos of angle XAB equals 8 centimeters over 10 centimeters. When we make angle XAB the subject, this is what we get. When we type this into the calculator, we get 36.9 degrees rounded to 1 decimal place. PQRSMT lie on the circle center O. Angle PST is 75 degrees and angle QTS is 85 degrees. Find the values of V, W, X, and Y. Chord PT subtends 75 degrees at the circumference of the circle and subtends angle V at the center of the circle. So V equals 2 times 75 degrees, which is equal to 150 degrees. OP and OT are radii of the circle. This makes triangle OPT an isosceles triangle. Base angles in an isosceles triangle are equal. So to get W, we subtract 150 degrees from 180 degrees and divide by 2. This gives us 15 degrees. Chord PQ subtends 2 angles at different points on the circumference of the circle. These 2 angles must be equal. So X is also equal to 15 degrees. The sum of the angles in this triangle must add up to 180 degrees. So to get this angle, we subtract the sum of 85 degrees and 75 degrees from 180 degrees, which gives us 20 degrees. Vertically opposite angles are equal. The sum of the angles in this triangle must add up to 180 degrees. So to get Y, we subtract the sum of 150 degrees and 20 degrees from 180 degrees, which gives us 10 degrees. Two containers are mathematically similar. The surface area of the larger container is 226 centimeters squared and the surface area of the smaller container is 94 centimeters squared. The volume of the larger container is 680 centimeters cubed. Find the volume of the smaller container. For similar containers, the ratio of their volumes must be equal to the cube of the ratio of their corresponding sides. We've not been given the sides of the containers, but we also know that the ratio of their areas must be equal to the square of the ratio of their corresponding sides. We want to get the cube of the ratio of their sides, so we take the power of 3/2 to both sides, and this is what we get. We can put this into the original equation. When we make Vs the subject, this is what we have. When we type this into the calculator, we get 182 centimeters cubed, rounded to 3 significant figures. Find g of 1/2. To get g of 1/2, we replace x in g of x with 1/2. So we have 2 times 1/2 minus 1, which is equal to 0. Find f of h of -1. First, we need to find h of -1. To get h of -1, we replace x in h of x with -1. This gives us 3 raised to the power -1, which is equal to 1/3. So to get f of h of -1, we replace x in f of x with h of -1, which we found to be 1/3. So we have 3 times 1/3 plus 4, which is equal to 5. Find g inverse of x. We've been given g of x to be 2x minus 1. So first, we replace g of x with x and replace x with y. When we make y the subject, this is what we get. This expression we have for y is the same as g inverse of x. So g inverse of x is also equal to x plus 1/2. Find f of x in its simplest form. To get f of x, we replace x in f of x with f of x. So we have 3 times 3x plus 4 plus 4. When we expand the brackets, 3 times 3x is 9x. 3 times 4 is 12. 12 plus 4 is 16. So we have 9x plus 16. Find f of x squared in the form ax squared plus bx plus c. F of x is 3x plus 4. So f of x squared is 3x plus 4 squared. When we expand the brackets, we get 9x squared plus 24x plus 16. Find x when h inverse of x equals g of 2. First, let's find g of 2. To get g of 2, we replace x in g of x with 2. This gives us 2 times 2 minus 1, which is equal to 3. Now let's find h inverse of x. We know h of x is 3 raised to the power x. To get h inverse of x, we replace h of x with x and replace x with y. Y is the same as h inverse of x. H inverse of x is equal to g of 2, which we found to be 3. So x is 3 cubed, which is equal to 27. Find the next term and the nth term of this sequence. The terms in the numerator are increasing by 1. So to get the numerator of the next term, we add 1 to 7, which gives us 8. The terms in the denominator are increasing by 2. So to get the denominator of the next term, we add 2 to 13, which gives us 15. So we have 8/15. The terms in the numerator and denominator are increasing by a constant value. So we can use this formula to get the nth term for the numerator and for the denominator. For the numerator, A1, which is the first term, is 3, and D, which is the common difference, is 1. When we expand the brackets and simplify, we get n plus 2. For the denominator, A1, which is the first term, is 5, and D, which is the common difference, is 2. When we expand the brackets and simplify, we get 2n plus 3. So we have n plus 2 over 2n plus 3. Find the nth term of each sequence. For this sequence, the terms have a constant difference of -2, so we can use this formula to get the nth term for the sequence. A1, which is the first term, is -1, and D, which is the common difference, is -2. When we expand the brackets and simplify, we get 1 minus 2n. For this sequence, we see that the third level of the differences between the terms is constant. This means the sequence is a cubic sequence. You can use the cubic sequence formula to arrive at the nth term. Another way is to directly identify the pattern. Once we know this is a cubic sequence, we see that 1 cubed plus 1 gives us 2. Then we have 2 cubed plus 1 giving us 9. Then 3 cubed plus 1 giving us 28. From this pattern, we can conclude that the nth term is n cubed plus 1. Thank you for watching. I hope you found this video useful. See you in the next video. Bye guys.